Hello and good morning dear students. So welcome back to online class. Today is 27th of July 2020 and today's topic will be integration by substitution in case of definite integral, and yes, we are starting exercise 8.17. Okay. Throughout this exercise you will find a similar type of sum which we have already done in integration by substitution in case of indefinite integral. Okay. The only new thing that we'll be seeing out here is the limits will be changed now. The limits will be changed because see, these are the limits. -1 to 1 are the limits of x. Now when we are substituting this to some another variable, let us say p, then we have to find the new lower limit of p, new upper limit of p. Okay, so let us start. Okay, so let us start. As we already know, if I just erase this, then we know what is the substitution, right? The substitution is x cubed plus 1 as p, isn't it? But here I have -1 to 1. We have to take care of that also. So this is definite integral. So substitution is same. This whole process is same till here. Okay? But now, see, the new thing out here is we are changing from x to p. The whole integral will be in terms of p now, dp. But -1 to 1 is the limit of x, not the limit of p. So therefore, we need to find the new limits of p. We have to find new limits of p using this substitution. Now, as we know that, we have substituted x cubed plus 1 as p. Now, how to find the limits of p? It's very simple. Take the lower limit when, this is the limit of what? X, isn't it? So when x equals to -1, put x equals to -1, you'll get the value for p. That will be the new lower limit. So p is equals to -1 whole cube plus 1. -1 whole cube is -1. So -1 plus 1 will be 0. So what is the new lower limit? 0. Remember that. And when x is equals to, what is the upper limit? 1. P will be 1 whole cube plus 1, which will be 2. So I got the new lower limit as 0, the new upper limit as 2. Okay. So therefore, we get finally, we will be getting this whole integral as lower limit. It was -1 in terms of x, but in terms of p, lower limit will be 0, upper limit will be 2, isn't it? Now I know x cubed plus 1 is p, so is it p to the power 4? Sorry, p to the power 3? This is p. Is it p to the power 3? And what is the value for x squared into dx? dp by 3 into dp by 3. How simple it is now. We have done this before in the previous exercise, so let us complete this. Pause the video till here, note it down. Alright, so after this step, come back out here. This is 0 to 2, 0 to 2, 1 by 3 constant, p cube, integration p cube, you know, p to the power 4 by 4. Okay, p to the power 4 by 4 from 0 to 2. So 1 by 12 constant, so put the upper limit, 2 to the power 4 minus 0 to the power 4, 2 to the power of 16, and this is 0, so 16 by 12 will be 4 by 3. The calculation is very easy. The only important part of it is take the proper substitution and then to find the upper and lower limit. Otherwise it is the same. Okay, we move to the next question. Pause the video and note it down. Next one we are taking is question number 1 part 2. I'm not going to solve this whole, okay, but I'm doing the hint out here. The question is 0 to 1 x e to the power x squared dx. Again, substitution. The substitution out here would be to substitute x squared. Substitute x squared as p, you get this. And now we find the limits. When x equals to 0, when x equals to 0, p equals to 0. When x equals to 1, p equals to 1. So the new lower limit is 0, upper limit 1. E to the power p, x dx means dp by 2. And now from here you know what to do, isn't it? So pause the video and note it down and complete this. This one will be your homework. I'll mention it at the end of the video. Okay, let us proceed. A similar type of question we have, that is question number 2 part 1. Now I hope if you remember, I've told you before, if there is numerator denominator, if the power in the numerator is smaller than the power in the denominator, we will substitute. If the power in the numerator denominator equal, make the numerator as the denominator. And the last one, if the power in the numerator is greater than the power in denominator, you have to divide. Okay, here it's the first case. The power is less than a denominator, so we substitute. Very easy substitution, x squared plus 1. So you'll be clear till here. To find the limits is very simple as well. We put x equals to 0, p equals to 1. We put x equals to 1, p equals to 2. So new lower, new upper. You get this 1 by 2 constant, integration of dp by p log p, upper limit minus lower limit, log 1 is 0, hence the answer is half log 2. Please pause the video and note it down. We move to the next sum. Let's move to the next question, that is question number 3 part 1. 1 to 2, 3x divided by 9x square minus 1 dx. Again the substitution is the denominator because the power in the numerator is less than the power in the denominator, right? So substitution will give you 18x. From here you simplify 18, I can write as 3 into 6, isn't it? So 6, drop it down, 3, keep it as it is and cross multiply with dx. Everyone is clear till here, I know. Now you just have to put the substitution, okay, the limit, put x equals to 1. When you put x equals to 1, 9 into 1 is 9, 9 minus 1, 8. When you put x equals to 2, 2 2s are 4. 9 4s are 36, 36 minus 1 will be 35. Very simple. So therefore we get lower limit 8, upper limit 35. 3x dx, dp by 6 divided by, this is p, isn't it? So 1 by 6 is constant. Integration 8 to 35 will dp by p, which means log p, 8 to 35, so log 35 minus log 8. Log a minus log b, that is a by b, so 1 by 6 log 35 by 8. Please pause the video. I don't think so there is anything which is not clear. Everything is very simple and to the formula, okay? So pause the video and note it down. Alright, so let us proceed with question number 5 part 2. We have integration 0 to 1 x by root 1 plus x square. Okay, again if you see the power is less than the denominator, but here it is inside the square root, so make the substitution as p square. So if you substitute as p square and differentiating with respect to x, we get 2p dp by dx equals to 2x, 2 gets cancelled out, so p dp is equals to x dx. We got the value for x dx, right? Now we put the limits. What is the lower limit? 0. So when you put x equals to 0, p square equals to 1, so p is equals to 1. And when you put x equals to 1, this is 1 square means 1, 1 plus 1 is 2, so p will be root over 2. Okay, so therefore the limits will be 1 to root 2, 1 to root over 2. This is p dp, x dx means p dp divided by root over p square. Square gets cancelled out, p by p also gets cancelled out. So 1 to root 2 dp, integration of dp means p, so root 2 minus 1. Please pause the video and note it down. Alright, please mark today's assignment. Very simple questions, okay? Question number 1 part 2, 2 part 2, 3 part 2, 4 part 2 and 5 part 1. And you have to send me by tomorrow along with today's work and today's assignment. That's it for today. Now one more thing I want to tell you out here, there are some questions which we have to skip out here because according to the reduced syllabus, the questions, some of the questions we don't have to do from here, so we'll do that tomorrow. We'll select the questions and we'll proceed in tomorrow's class. Okay, so that's it for today. Practice it properly. I'll see you tomorrow. Thank you.